in this video, we're going to talk about inner classes. Sometimes these are also referred to as helper classes. And what we're going to talk about here is first a little bit about how they're defined and then what they're used for, as well as their syntactic and implementation structure and design within Java. So if you're familiar with a struct from C++, this is similar to a C++ struct. Okay, so we're going to use them for similar purposes, basically as a way to help our outer class, our main class that we're working with. Structs are little pieces of data that we can contain things in, right? Similar to a class in Java, but a little bit less formal than a class. This is going to be really similar, except that we have to define an inner class within an outer class. Okay, so we have to have a base class, not a base class. Base class is used for other terminology, but we have to use the main class that we're working with. The reason why we're making this inner class, we have to put the inner class inside of that outer class, and that's what we call it, an outer class. So we're just going to do a brief little example here, and I'm going to use the terms inner and outer class as our class names, so that it helps us determine which one's what for the purposes of this demonstration and lecture. All right, so we have a public class, and we're just going to, again, call this an outer class. All right, and this is an outer class, and that's all we're going to do with it. We just have a nice little outer class, and then in here, we're just going to straight up do another class instantiation. So we have public class, outer class, and then inside that we're going to have public class, inner class, just like so. And then we're just going to have, inside of our inner class, we're going to have all sorts of code. We're going to have variables. We are going to have methods. And these are going to all have their different access modifiers. They're going to have their own, structure, design, everything that you would think that a normal class should have. This will have it as well. Now, this is a way to do when we need to do composition. So when we need to make a class out of multiple classes, this is a way we can do that if that secondary class, that helper class that we're making, doesn't need to be used outside of our outer class, outside of the main class that we're working with. So after we have our inner class declaration and definitions, we can do our outer class. So after we did our inner class, we can do our outer class variables and methods. This is the usual way we design these inner classes, the way we write them and organize them in Java. It's just convention. I don't think there's anything that requires it to be done in this order. It's just the way that we typically do it so that the code's easier to read and that we know what we're doing. All right, so this is generally what it would look like to do an outer class with an inner class. And remember that we can still do an extends or an implements on either of the outer or inner classes. That is fine. That is something Java allows. And it's important to remember how you would need to do those. We're not going to be talking about that in this video, but it's just important to remember that you can still use the extends and implements keywords on both the outer and inner class. All right, so things to remember, things to know about your outer and inner classes. So the inner class can see all private data. Now, it doesn't matter if this private data comes from the outer class or the inner class. It can see and access it. All right? Now, this is also true of the outer class. The outer class can see all private data as well. All right, so the outer class and inner class can see each other's private fields. Nothing is private from each other. They're basically like a married couple. They talk to each other all the time. They know about everything about each other. They don't keep any secrets from each other. All right, now that's a very broad definition of a married couple, so don't take that too literally. But the idea here is that they know each other very, very well, and there's no keeping anything private from each other. There's no security between the inner and outer class. Now, something else that's important to remember is the inner class can be marked private. Now, when we mark it as private, what happens is that inner class is no longer accessible from outside of the outer class. All right, so it can't be accessed from outside. I cannot write today. From outside the outer. Okay? And other than that, inner classes can be static, private, or public. All right? So we still get all of our access modifiers. We get static, public, and private. Note we don't get protected. All right, so we're only talking about static, private, and public. Now, with the private, right? So, well, generally, if we're working with this public data, actually. So, if the data is public, if the class is public, then what we can do, if it's static, all right, and we're trying to access it from outside of the outer class. All right, so if we are, let's rename our outer and inner classes a little bit here. So we're going to rename our outer class here. All right, we're going to rename that to be, we're going to call that A. And we're going to call the inner class here B. All right, so outer class A, inner class B, just for ease of discussion here, because I keep saying outer and inner class may be a little too much. So if we're trying to access the inner class or class B from outside of the outer class or class A, then what we're going to do here is we're going to say that we need A dot B, all right, so the class name dot B, the inner class name, so outer dot inner, and then we're going to get a variable name, so let's just say X, and then we're going to say is equal to a new outer class, in our case A, dot B, and that's going to instantiate a new copy of that inner class. Now this only works if it is static and public. Now, if it's not static, okay, this is going to change how we do it. So this is static here. If it's non-static, we are going to do something different. It's going to look a little bit different. We're going to do outer class, so A dot B, just like we saw above, okay? We're still going to do a variable name. So let's say that this is Y this time. And instead of doing that new where we did it before, it's actually going to move a little bit. We're going to do A dot new B. Okay? So what that looks like, another way to look at this is we have outer dot inner, and then we have a variable name, right? And then from there we have our new and then it's outer dot inner and the instantiation. Okay? And then if we're doing it with non-static, it's outer dot inner, just like before, with a variable name. And then we have new. Actually, we don't have new there. My bad. Sorry. Hold on. So we have outer dot inner variable name equals, and then we say outer, and then we say dot new inner. Okay. It seems very awkward and different, but it's important to remember the differences here because if you're using them, it's really going to change how this works for you. And it also changes, clearly it changes your syntax, your code, but it's also important to keep in mind whether or not you need something to be static, public, or private. Now, in most cases, you're probably just going to keep things as private. Doing a private inner class is really common. And the reason for that is because if it's a helper class for your outer class, then it's not really something that's probably going to be that useful outside of your outer class. Now, in a case where you might want it to be accessible out of that is if you need to return something of the inner class type. So if you want to be able to return and handle that data outside of your class. But again, that's really a unique situation. You're probably not going to come across that much. And I want to go over an additional example of something we might do here. So we're going to just look at doing something with the example that's in the book. I'm looking to see, yeah, okay. So in the book example here, all right, we're going to just talk about this bank account. So they have a public class bank account. All right. And inside of that, they have a public class money. All right. So in this money class, they basically have some things to instantiate a number from a string. So instantiate a value from the string. So there's a constructor and there's a get amount and a add in and abort methods. All right. So there's some various methods in here. And we're not really going to talk too much about those because that's not what I want to talk about. I just want to show what it looks like when you write it. You can look at this example yourself with all of the detail on page 740 through 742 of your textbook. So we have public class bank account, public class money with methods inside of there. And then after that, we actually don't close this out yet. We don't close out bank account yet. There's going to be a variable in here and a variable for the bank account that we call private. It's a private variable and it's of the type money. And we're just going to call it balance because that's what the book calls it. All right, and this gets instantiated when the class constructor gets called for bank account. All right, so we instantiate this private variable just like we would instantiate any other variable that this class might have. Now, when we want to do certain things, we might interact with this in some particular way and use the methods that are described in money. And in this particular example, you'll note that the access modifier on the class is public, right? So on the money class, we have a public access modifier. This means that when we interact with this public class, that we don't have to do some of the things, like it's not only public, but it's also non-static. So it's going to follow the more, I would say, unintuitive way of interacting with it, which is this bottom one down here. It's this a dot b equals a dot new of b, right? So again, it's not entirely intuitive how this works. So it's really important to remember that the static versus non-static does change your syntax and how you interact with things. It's also important to remember that just because this is private, this instance variable is private, right, does not mean that that helper class is private because we defined the money class itself as a public class. So we can see it and access it from outside of bank account. All right. If you have any more questions on what this looks like or how this works, there's a lot more detail in the book, pages, what was that, 740, all right? So pages 740 through 742 have examples for, well, one big example for how this would work and what this would look like. If you want more detail on it, there's also a little bit more text on having an outer and an inner class, but this is really going to cover most of what you need to know and covers the concept of how this is defined. We're not going to use these very frequently. You may find yourself wanting to use them here and there, and that's great. You should do that. Remember that we mostly use these when we need a way to kind of wrap our data and use it within our outer class, but not usually when we need to. We don't usually use this if we need to use that outside of our outer class. And when we want to do something like that where we want to make it public, if we were going to do that, you might actually want to do something called composition, which is where you take multiple classes. So we take our primary class that we're working in, and you would have another class that we wrote, and you would import that other class into our primary class. You'd import it and use it as a variable. You wouldn't use it necessarily as an inner class. That's going to be much more common than doing something like this. And the reason why that this is even an option is because there's times when we don't want to have another class that's separate from our primary class. This happens a lot when we want to encapsulate all of our data into a single package. We want to encapsulate all of that into a single package, but it also can be used to improve readability. It can be used to improve basically the general design of your class. For example, let's say we had a line class where we had 2 points and maybe a slope. We would want to keep 2 points as data objects within our class, and maybe we would say that Java didn't have a point class, so we had to write it ourselves. So we would write an inner class of type point so that we could keep track of that point data, and we might do something to calculate the slope between those 2 points when we instantiate it initially. This is just one example of why we might use an inner class. It's not necessarily a great example. Again, this is really just used when we want to get data from inside of that outer class, inside of our primary class, wrapped up a little bit to improve readability, to improve encapsulation, that kind of thing. But also remember that inner classes and outer classes share all of their private data with each other. There's no hiding any of that information from each other. It's all basically public as far as they're concerned interiorly to their method calls and to their data calls. All right. So that is it for this video. Next video series will cover array lists and generics.